Hello, my name is Selena Sanchez, and today my presentation is over phonemic restoration. So to start out, I want to talk about perceptual restoration. As early as 4 months, infants can begin to use perceptual information to fill in occluded stimuli. So they could look at an image or like a person, and if it's clearly covered, they can use their perception to fill in the blanks. Another form of perceptual restoration is phonemic restoration, which is what I'm going to focus on today. Phonemic restoration has to deal with auditory stimuli. Okay, so a phoneme is a part of a word. It's like a unit. So some examples of that would be the TH sound, the CH sound, sh, and the K sound, k. So it's like breaking down a word. So phonemic restoration happens when a phoneme is masked or missing. And we use our previous linguistic knowledge to apply it to the to fill in the missing information. Other cues that we use during phonemic restoration would be our expectations in linguistic knowledge, our syntactic, semantic, and lexical constraints, as well as contextual cues. Not only does phonemic restoration apply to basic speech, but there's evidence that is present in like the music domain. So that suggests that it's not only for speech and music, but it's also for like many different auditory domains. Phonemic restoration uses both top-down processing, which would include our previous linguistic knowledge to create expectations of what we might hear, and then bottom-up processing to confirm those expectations. The book gave us an example, so I just wanted to go over that really quickly. It's Warren and Warren's study that took place in 1970, and it looked like the following sentences. They were presented to the participants, I think it was like in a voice recording, and where the asterisks are, a cough was present to mask the phoneme. Because of phonemic restoration, the participants were successfully able to identify the word will in the first sentence, hill in the second sentence, and pill in the third sentence by using contextual cues. Here is a visual interpretation of how a study might look like. So you would take, like in this study, they did story A, they asked questions about story A, did story B, asked questions about story B, and then did story C. And then in part B, it actually shows you what it would look like unmasked, and then what it would look like masked. It doesn't change the duration, and it just does the exact same thing, just putting a small mask over a phoneme. Now to talk about some of the articles that I read, my first point is age differences. The study suggests that our younger children have difficulties interpreting missing phonemes, being greatly affected by signal interruptions. So they need the quiet environments because they don't have the skills necessary to use phonemic restoration. They cannot use phonemic restoration to the same degree as adults, but phonemic restoration was evident in all ages. Although individuals, no matter the age, showed presence of the use of phonemic restorations. It also suggests that clear evidence of occluded phoneme is necessary in the ability of our phonemic restorations. So all groups had difficulty using phonemic restorations when the gaps were silent filled than when they were noise filled, because when the noise was filled, it provided evidence, clear-cut evidence that it was masked and it needed to be filled again. The evidence also found that it suggests that phonemic restoration develops significantly between the ages of 4 to 11 years, meaning 4-year-olds have a lot of development to undergo. That's why it's very necessary for those younger children to be in silent environments. Adults scored better in the study, suggesting they are able to undergo the full illusionary experience of phonemic or perceptual restoration. Which is when you hear the phonemes, whether or not the stimuli was actually present. Okay, I have included the graph of the previous study when I was talking about the age differences. You can see clearly that the adults had more experience, and the older children had more experience than the younger children, and you can see the same patterns for each age group pertaining to perceptual restoration. Next, I wanted to talk about the other variables that can also go into the age difference as far as like hearing and like phonemic restorations. One age difference could be affected by less knowledge and experience for top-down processing to occur. This can be found in our younger children because they don't have the experience as far as contextual cues or like linguistic knowledge to be able to use top-down processing as easily as adults can because they do have that experience. In older adults, another age difference is that in phonemic restoration, it could decline because of hearing complications caused by loss in cochlear hair cells and acuity, which is why you see a lot of the older ones wearing like cochlear like ear implants and stuff like that, because there are complications and that could go into how and why they are able or not able to use perceptual restoration. Now, as far as the location of the brain regions, using MEG in one study, phonemic restoration was found to happen in the left transverse and superior temporal gyri. These brain regions are responsible for the first processing of speech information for speech comprehension. It is also evident that phonemic restoration occurs also in the left inferior frontal gyrus, which is responsible for our ability to unconsciously repair missing and occluded information. And lastly, I just kind of included how the study had listed the regions. It also shows the way different methods of locating like coordinations as far as like the BA and stuff like that. And so if you wanted to look more into that, it's there. And yeah, that's all I have.